Great.
Maybe
Alright,
I missed the class. Sorry, I missed the class.
you're not getting what I'm saying. It doesn't matter. Right. Can you just move it a little bit to the left, please? Keep going.
Okay.
Do you watch Legends of Tomorrow?
Yes.
What do you think?
They just
Not
no,
great.
they just I don't know the word to use. Just made
Ripped
them
off?
feel like losers because they took the useless people from Flash and Arrow to Delta.
Well, useless. B rate.
No. No relevance to the
That's right,
timeline.
Messing with the name of that app.
Yeah.
The app
That
they use as a Netflix something.
is an electric one.
Netflix, like you go on the watch, you
Oh,
watch.
popcorn time. Popcorn time.
Popcorn time.
I know that one. Yeah. Alright, next near the end of this chapter. Alright. Come on, Fahad. Come on.
Okay.
Say what? Alright, so transformation of functions now. So actually, it'll be a bit useful now if I open up the graphing program. So you might remember we did a bit of this in semester 1 when we were looking at sine, cos and tan. So, for example, do you remember when we had y equals a sine b x minus c plus d? Do you remember what each of the letters do?
Yes.
So what does the a do?
Shift it up. No, make it stretch. Stretch it.
Yeah. The b?
Move it up,
Oh yeah, this
up
one.
or down.
Mm-hmm.
No. Make it 2 times as long or 3 times as.
Not quite. The b compresses horizontally. The c
Make it longer as well.
starts so well at a. The c
You see, makes it move up or down.
Transformation.
no, left or right.
Left or
In
right.
this case to the right. The d.
Up or down, yeah, obviously.
So these rules work the same for any function, not just sine, cos, or tan. So we just want to make it extremely clear what they do. So just to recap, if you multiply a function by a, this, now I need you to write these down because in the exam they often ask you to describe the transformation. This will expand.
So we need to remember the definition of all of them.
Yeah. This will expand the graph by a units along the y-axis.
How many are there? 7, 6,
Huh? 4, A, B, C, D.
No, the like transformation,
Enlargement.
Oh no, we don't worry about that.
That's construction.
You don't have
Yeah.
anything for this?
Not for this, no. You're talking about reflection,
Yeah.
enlargement,
Refraction.
Can say something scale.
scaling.
Yeah.
Yeah. Okay, the next one is if you multiply the x by b. This, what will this one do?
This will compress.
Yeah.
So that means if A is equals to B, the graphs are the same.
This will compress the graph by b units along the x axis.
Okay, so look.
Got that?
Okay.
Yeah.
So next one is y equals, do you want me to write plus or minus c here?
Plus.
Plus c? Okay, well then if it's plus c, it'll move it to the left.
Yes.
Yes, the reverse.
This will translate, which means move, the graph by c units to the left along the x-axis.
And it's minus the other way around.
Yeah. Okay, got that one? Yeah? Okay. Next, y equals fx plus d. This will translate the graph d units up along the y-axis. Okay. Got that? Yep. So let's have a look at an example. So suppose I have something like this, for example. Y equals 2f 3x minus 6. Let's make it a minus 2 as well, plus 4. Oh yeah. That's what you should be saying right now. Bring it on.
So it's a what? What?
Got this? So first thing you need to do is take out that
Minus
minus, well, you don't have to, you can leave the minus in there, but you certainly need to take out the tray here. So this is the A, this is the B, this is the C, and this is the D. Yep.
Okay.
So, what does the A do here? What does the A do?
expand it by minus
And
So first we expand by 2 on the Y. And what does the minus do on the 2 though?
Make it go down.
No?
Translate.
No, 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 no,
No,
Contract.
no.
minus the units.
What?
Minus the units.
I don't even know what that means, but no.
Opposite way.
Yeah, so the minus flips the graph. Remember? Like x squared minus x squared. A minus in front flips the graph. You forgot that? Yeah, you forgot that. So, this one, what's the verb? We say reflect. Reflect true x. The
Which one
true.
reflected? Which one is to
Reflect
reflect?
to
The minus here.
Minus here.
to
The tree here
Compress.
compresses along x by 3 units. The minus 2, you move right 2 units. And lastly, the 4,
you mean by 2? Minus 2?
no, no,
No, the C.
Move up.
move right 2 units is correct.
No, I'm just.
The minus 2, yeah.
Translate.
Move up 4 units. Right. So let's test this out. Tell me when you're ready.
Like we have to follow, like A, B, C, D.
The order
Yeah.
must be followed. Yeah? Okay, so, have you got this correct?
Yes.
Are you sure?
Yeah.
Right, because I'm going down. So let's imagine I have a graph like y equals fx, and let's just say it's the good old simple x squared. Right, here is plain old happy days x squared. What was the first step in my transformation process? So sorry, to be clear, in red is y equals fx. And what did I say fx was? X squared. And in blue, I'm going to draw this in blue. Alright, so what was the first step here?
Expanded by 2 on y.
So,
Wait, I want to see what okay.
expand by 2 on the y. So that means the graph looks like it's 2 times taller than it was. So it's like it gets lifted, stretched up. So I'll draw it. Firstly, it goes like this. What's the next step? No. Reflect. So then it'll flip down like this. And then what's next? What could possibly be wrong? What's wrong?
No, I'm not asking.
What?
The first one is expand.
The first thing is what I did first.
A.
Yes. Which was what? Expand on the y, wasn't it?
Yeah.
Yeah. So you go,
Oh, okay.
may I continue?
Yes.
Flipped. What's after that one?
Compress x by 3.
Compress along the x
X
by 3. So that's making it look really skinny now. What's next?
Move right 2 units.
Alright, so I don't know where it'll be, but it'll be skinny and over here now.
Move up 4 units.
Is that the last step?
Yep.
So I'll do that in blue. So I'm expecting some skinny, squished graph like this.
Yes.
Well, there's only one way to find out. Let's have a look. Right, so fx was x squared, y equals fx. So there it is. Now, the next one I want to draw is the graph which is transformed. So, what is it? Minus, give me the original, minus 2 f 3x minus 6. Yeah,
Plus 4.
this is it?
Yes.
Alright.
Probably something like that.
Where'd it go? Hey! Alright. Let's zoom out a tad.
So I got it.
Nice. Satisfying. Yeah. So, if I could go back here. Can I just go down? Yep. Right, so, let me just give you a good idea of what's happening here. So suppose I told you y equals fx equals x squared, and I ask you to draw this. That's easy peasy to do, right? If I ask you to draw this, it's the same graph, but shifted to the right. But what is fx? What's fx? X squared. So that would be x minus 1 squared, which is equal to x squared minus 2x plus 1. So what I'm saying is, you don't need to simplify this into this. You can just look at what you're doing here to work out how the graph is changed. Alright, so like if I was to go back here, if I was to replace the x with 3x minus 6 in this formula, I would have minus 2, 3x minus 6 all squared plus 4. Because remember, fx is just x squared. So it's just this piece is like 3x minus 6 squared. So if I graph this now, you see I get exactly the same graph. But of course, simplifying this to be able to graph it, you could simplify this, you could find the roots, you could find the turning point, and you will get the same graph. But the whole concept behind transformations of graphs is that you have a way to draw new graphs without having to work out the new formulas by just looking at what you're doing to the function. Okay. Right. Let's do this graph. Y equals fx, which equals. Now, what I want to do is I want to have a graph. Actually, yeah. Let's take this exact graph. Minus 18 x squared plus 72x minus 68. Now what I want to do is find out where the turning point is. So derivative, simplify, solve when it's equal to 0. So it'll be at 2, and if I put in 2 for x, 2, 4 is where the turning point is. Okay. So fx equals that. Right, back to here. So I know, let's imagine I don't know this. So I just say, here's a graph, it looks like this, and this graph has a turning point at 2, 4, and y equals f of x is the graph. But we don't know the formula. A common thing they like to do in the exam is to give you a transformation and ask you where will the new turning point be. Okay, so let's say for example I give you this transformation, 2f 3x minus 4 plus 5. And we want, and I'm going to put a minus here as well. We want to know where will this new point be on the new graph, whatever the new graph is. So we apply our rules, but we make sure we keep track of how the point changes. So, well, firstly, what I need to do is take out the minus 3 here. So what would I be left with here? X plus 4 over 3 plus 5. Okay, so let me start with the point 2, 5. Right. A, B, C, and D. So what would the A do to the graph?
I see 2, 5.
Hmm?
I see 2, 5.
Oh, sorry, 2, 4, isn't it? Sorry, thank you. 2, 4. Okay, it'll expand it by 2 on the y-axis. So if you visualize this point here, what would happen to it?
Go
Go.
Up it would go
2 points.
to a new higher point. In fact, the A part here would have it landing at 2, 8. Now how did I get the 8?
Just
Multiplied the y by 2, got expanded 2. Next, let's do the B. So what would this B do? Compresses on the x, and the minus flips the axis around. So this would be, it wouldn't be 2 over 3, but it'd be minus 2 over 3. So the graph gets compressed by 3 units, and it gets flipped around. So the positive x's become negatives, and the negatives become positives. Okay? Now I'll show you all of this in the program as well, so you can see it happening. Right, next is the C. So what happens with the C here? It moves it to the left 4 over 3 units, so that would become minus 6 over 3, which is minus 2, and 8. Minus 2 over 3, minus 4 over 3 is, because you're moving it to the left.
Okay.
No, is it really okay? Are you sure?
Yeah.
And then lastly, the D, what was the D going to do here?
Move it up.
Moves it up to 12. No, 13. Gets raised. So the D increases this point by 5 units.
Clear that now?
Now, I'll go back to it now in a second. I want to show you it on the program, and then I'll go back to it. So, firstly, let's graph this. Look up, everybody, please. I won't delete any slides. I'll give you a minute to write it down. So there's our original graph. Let me just open it up a bit here. Right. So where's the maximum? There at 2, 4. What was the first thing I did?
Expand.
By how much? 4, was it? 2.
2.
So let me graph that. And you see, as we said, up it goes. So now you can see that the maximum is now at 2, 4. What was the next thing I did?
Compress. For minus 2.
I did it was a minus 3x, basically. Yeah.
And you know the blue line in the
Yeah.
they have the different x, like a bit different.
The
Not
x
in the no.
here,
Near minus 8.
near the
Y.
minus 8.
Yeah.
Yeah, what are you asking me?
So this will change the different values if you go further.
I'll zoom out for you if you want.
Yeah.
They are different. They don't meet.
Yeah.
Like these are different places down here. Yes. What was next? The minus 3.
Yeah.
So I said that compresses it
Mm-hmm.
and flips it around. So before I draw it, I want you to picture the blue line. Imagine it compresses. Now, this is the thing. When it compresses, it doesn't compress like this. I'll go back to that. Don't worry. When I say it compresses, don't think about this piece compressing, but think about it compressing to the y-axis. So if this was on a piece of paper, imagine the paper got squished together, this would crumple over towards the y-axis. So this gets compressed to the y and flipped around. Now you know what, I'll do it in 2 steps actually. I'll do the non-flippy part first. So I've got compressed to the y, and then when I stick the minus in it, it gets flipped over. So now we're here. What's the next part? What is the problem? What is the problem? I'm hoping I'm being really clear with each step of the graph here. So what could possibly be the problem?
No, last time you
Yeah,
in the x-axis, this one.
yeah. This flips around the y-axis.
The last time we did on this.
flipped around the x-axis.
And that was because of.
Because it was a different question.
I
Yeah?
know, but.
Because the minus was on the f, but here the minus is on the x. Is it?
Yeah.
Now, what was the next thing I did? Or the last thing I did?
No, two more.
No, two more things. What was next?
No, move it left 4/3.
No, but what number?
4/3.
Oh yeah, but originally,
Four.
it was a 4, yeah. Okay. So now you see, wait, minus 4?
No, yes.
Did I type it in wrong? That's minus 4. Now, what's a little bit weird is because when I did it, I took the 3 out. So really, when I did it, it was like this, wasn't it? And what did I have inside here?
4/3. Plus 4/3.
Yeah, plus 4/3. Is that, I can't even see, is that it? Yes. Now, I have so many graphs going on here, I'm losing track. Yeah, so it's still the same thing. I've lost my graph. I don't know which one it is anymore. Anyways, we only have one left to do.
The last one.
Which one's the last one?
Say it one now.
We'll just go to the last one. What was the last piece of thingy I did?
Plus 5.
+5. So the one graph should now jump up. Look at the colours. There it is. Can you see it?
Yes.
The blue one.
There it is. So where is the maximum? It looks like it's at -2 and
14, 30.
something like this. -213. The maximum -213. There it is. There. Yeah. Now, if I go back to my program, if I simplify this, if I put in the numbers and simplify what I get, so simplify this, I get this quadratic. If I calculate the derivative of this quadratic, and then solve for equal to 0, what should the x be? Should be -2, and it is. And if I sub it back into the quadratic, the -2, what should I get for y? I should get 13, and I do. So this is exactly right. Now, in the exam, often what they ask you to do is they give you a function, they give you a point, they don't give you the formula, they give you the transformation, and they ask you 2 questions. Part A is describe all the transformations, and then part B is where will the point be on the final graph, the new graph. So for this question here, we started at 2, 4, and then on the final graph we finished at, what was it, -2, 13. And what you'll notice here is you don't need to know the formula for fx. You just need to know what the transformations are. Okay, so...
Give us the transformation.
Oh yes. So they'll give you, the question will look like this, and they'll give you a point, and they want to know where will the point finish up on the last graph.
It cannot be not longer than
This is maximum difficulty setting. Well, no, maximum difficulty would be then if I had a minus here as well. Now it's maximum difficulty.
Does she ask for graphing?
Yes, they sometimes ask you to draw the new graph. So, you see in the last question where we started in red and finished in blue, they would ask you to do this in the exam.
this. Need to play with the font.
Yes.
Can I have that?
Yeah, so you want to write this part down. Okay, so I'll write this down.
to make it easier than the last one.
Like what easier? This?
Yeah.
No, this only seems easier because you've already done it before. That's why. That's the only reason why.
I don't think so.
No, it is. It really is. Because first time it was, wow, what's going on? It's transforming. But now it's like transformations, transformations. This is simple.
Yeah, we know this one, so this is why we come.
Yeah, that's all. Except we're doing more difficult problems with it.
So, in the A-level book, you need to transform and just expand and blah 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 blah.
Yep, that's right.
You have to explain everything.
Mm-hmm.
No, we don't have.
Now,
Example?
not really an example, just something that occurred to me when I was doing the last example. So, imagine I have a graph that has a graph like this. Now, it doesn't matter what the graph is, but let's pretend it's like that for a moment, okay? And then I want to graph this. So what happens here? Does the graph move left or does the graph move right?
Right. No, left and up.
Left. Move left.
Left.
Left?
Yes.
Yeah. We all agree that the graph moves left?
Yeah.
Because?
We bring minus for now.
Because of minus x.
No, it moves right.
Now remember, this here is the graph of this, with the minus in it already. So, for example, if you want to be extra clear, let's imagine this is fx here. So this one here is f minus x. So my question is f minus x plus 100. Where should that be?
Oh, move to the left.
Now why move to the left? From which? From here, A or B? You move A to the left or B to the left?
B to the left.
So move B to the left.
Yes.
Yes? Are we all thinking the same thing?
Yeah.
Yeah? Which I think is wrong. Because, now the reason it's wrong here is because the minus here. Wait, did you say move A or B to the left?
B to the left.
Let's see. So, let's make a simple graph. Let's say something like fx equals, I don't know, x minus, x plus 10 squared. Right, so let's graph that, fx. So there it is on the left. And we're all happy that f of minus x, that will jump to the right. So then f of minus x plus 20, should that be on the left or should that be on the right? Got 50-50 chance here. We are thinking. Anyone want to commit to an answer?
Right.
What did I say before? Left. B to the left.
No, left. Left.
Why?
Left.
To the right.
See, that's what I said.
Now, it seems a bit weird because in the explanation I said, well, the plus here would make it move to the left. But you need to be very careful. In my definition, I said if you have fx plus c, it will move it to the left. If you have fx minus c, this will move it to the right. Now, don't write this down because this is in your definition. But I never said anything about f minus x plus c. And if you think about it, that's like f Well, I suppose if you think about it, the C has an opposite sign to the minus, which is a bit like this situation here. The sign is opposite to this one, which makes it move to the right.
So minus x plus c, right?
Yeah, it moves it to the right.
Because if we take it out,
Yeah, it's to do with if you take it out. So if you take the minus out, and you have x minus c, then we agree that this one moves it to the right when it's acted on an x by itself, and then the minus will do something else as well. This can get quite complicated. So anyways, I guess I just want to say, they'll never ask you to draw the graphs in between. They'll only ever want the first graph and the last graph. But I just want you to be careful. As you're transforming it, if you were to look at the computer program, some weird stuff that you might not expect happens. So like for example here, you might have thought that when you add the 100 to this graph, it should make it move to the left. In fact, it makes it move to the right. But these aren't things to worry about. If you just use the rules I gave you at the start, you'll get to, as you saw each time, you got to the right answer. Yeah? There might be some weird behavior in between that you might not expect, but you'll get to the right answer in the end. Okay. Yeah, I suppose I just want to start the next topic, but I do want to actually finish with this. So imagine I said y equals fx, and I transformed it like this.
right.
Okay? On the new graph, the minus has already affected the x. So what you could do is you could say let new x equal minus x, like the old x. Or often, if people have studied transformations before, they usually put a little tick on the x. So that becomes then minus x. New x becomes minus the old value. So this new graph which you've drawn already has the minus on it. Yeah? So if you have plus 100, it doesn't move it to the left, it moves it to the right, because in the new system the x gets a minus. So a bit like what we were saying earlier, you have to take the minus out. This has become minus 100. I'll stop talking now, because it's getting much more complicated than what you need for the exam. For the exam, if you can do problems like this, where you have a function, you have a transformation, and they ask you to draw the new final graph and the point to move it to the new graph. That's all you need for the exam.
The last point.
This example here.
Yeah.
Yeah? But I'm just trying to explain why, if you were doing this on a graphing program, you might get some things you don't expect. Right. What ones I would like you to... What you should be able to practice at home...
Last time, 2-0.
no, just like the last two from each is enough of a practice. Yes.
So when is the midterm test?
There's no midterm test in semester 2. I'll give you a progress test if your tutor wants me to. But I haven't planned on giving you a test. Wait, but if...
What?
Who's your tutor? Who's your tutor?
You know, if you have a test,
Who's your
good for
tutor?
it.
Yeah, if Connell asks me to give you a test, I'll give you one, but I wasn't planning on giving you one. What's your
When?
question? I wasn't planning on giving you a test. I'll only give you one if Connell asks.
Okay, I want this.
Huh?
Green.
Go ahead.
Huh?
This month.
This month?
Yeah, after 15 weeks.
After the February holidays.
After 2 weeks. 3 weeks.
Right, I'm closing this now.